let's get started with today's Leetcode challenge, that is Leetcode 3783, mirror distance of an integer. So this is an easy problem, and let's read this out. You're given integer n and define its mirror distance as absolute of n minus reverse of n, where reverse of n is integer formed by reversing the digits of n. Return the integer denoting the mirror distance of n. Absolute of x denotes the absolute of x. So here, if you see the example, n is equal to 25, output is 27. How? So reverse of 25 is 52, and when we do the absolute difference between 25 and 52, it's 27. So this is actually a very simple problem. There is two ways to solve this problem. Let's discuss that. So there is two approach. One is simply when the number is given to us, what we can do is we can simply convert the integer value to string. That is, in C++ we can do it using to string. This will give me a string value. Okay, and then what we can do is we have the string value, we can reverse this string, and this will give us the reversed string value. And when we get the reverse string, we can get the integer value from the string. So in C++, so this is basically string to integer. So this is in C++, we can do this using this stoy method. So this will give us the integer value. For example, if we take the above example, so number is 25 and is 25. Okay, so what we do is number is 25. So two string of n would be 25 as a string. Reverse of 25 would be 52. Again, when we convert this to integer, this will give us 52 as an integer number. Now what the question has asked, we need to do an absolute difference between n and the reverse value. So absolute difference of 25 minus 52 at the end, which we have to return, which is 27. So this is one way to solve this problem. And here, if when we look at this problem, so what is the time complexity for this problem? So if we see time complexity for this one, it's like one operation in which we are converting it to string, then there is another operation where we are reversing it, then there is another operation where we are converting it back to integer. So usually this reverse of this number will take 10 to the power so basically at max, if we look at the constraint, so constraint given to us is that n can be at max 10 to the power 9, right? So at max we will traverse to 9 digits. Basically 10 to the power 9 is 10 digits, so total number of digits in that number we have to reverse will take basically that much time. So what is this number of digits I can write. Okay, for now number of digits is the time that it is going to take. And space complexity, if we see, so at max, as we see, like reversing, we are using an additional string to store this value, so it would take additional space. At max it can be, since our constraint is number can be at max 10 to the power 9, so it would be at max of 9, let's say. Okay, so this is one approach through which we can solve this. Another approach is using maths. Now let's solve this problem using math. Okay, with math, how can we solve this problem? So if you know how is this number 7829 is formed, it's basically 7 into 10 to the power 3 plus 8 into 10 to the power 2 plus 2 into 10 to the power 1 plus 9 into 10 to the power 0. Okay, so that is how the number is formed. What is the reverse value of this number if you see? So it is 9287, right? This is the reverse value for this number. Now, if we want to form this number, what it would be? So it would be simply 9 into 10 to the power 3 plus so on plus 7 into 10 to the power 0, right? So this is how we would form this. Now, if you see, to start forming this, what is the first number that we can get? So first number is 9, right? So how can we get 9? If we do mod with, mod of this number n with 10, we would get this value 9. Okay, so we got 9. Now we will do something to this. Now what is the next value that we need to form? That is 2, right? How can we get the 2? So 2 9 we cannot get, right? Let's say if we would have divided n by 10, then what would the value would be, the integer division if we do? So this would be 982, right? And again when we do the mod to this value, we would still again get 2, right? Okay, now again let's say if we divided this value with 10, so it will be 78. Now if we do mod of this value with 10, then we would get 8. Now again if we divide by 10, this is this value. Now again if we do mod of this value by 10, then it will give me 7. Now again when we divide, then it would go to 0. So this is how we can get this value, right? But if you see, simply we cannot add them together, right? So for that reason, for having this value added, if you see, right, this, if we have our number 9, right, eventually if you see, it has the highest power, right? And this power that is keep increasing for every number. So it is 10 to the power 3, 2, 1, 0, like that. So what if we could have done it something like this? Whenever we get this number, we multiply it by 10. And so initially when reverse was 0, what we do, we multiply reverse into 10 plus get the mod value. So what was the initial? These are mod values, okay, every time. So what was the mod value to us was 9, right? So in this case 0 plus 9 would give me reverse as 9, right? So what would be the next operation? 9 into, again we would do 10 plus what is the next mod value? 2. So it would give me 92, right? Now again when we do the next operation, so yeah, next operation, so it would be 92 into 10 plus next mod value 8. So 8, it would give me 982, right? Now again if I do it, 982 into 10 plus what is the next mod value? 7. So it would give me 9827, right? And this was the, and when we came here, how did we stop? Because there was no further value to get the mod of, right? N is equal to 0 we reached. So this is the number which is the reverse of our given number. So in that way we are able to simply find the reverse of this value. So when we combine these two things, the calculating mod part and every time multiplying the current reverse value with the 10 and adding the mod value to it, we are able to get this solution, basically reverse. So altogether when we combine this, so what we are actually doing, we have this reverse method which has this number n, and let's say a reverse variable which is initially 0, and when till when we are doing till the number becomes 0, right? So let's say while n is greater than 0, and what we are doing is we are the current reverse value into 10 plus now we are adding the mod, but how did we get the mod, this mod, right? How did we get this mod? So this mod is basically every time the number we are doing the number mod of the number by 10, so n mod 10. But to get the next mod rightly, we were dividing that number by 10, right? So what we would do is n is equal to n divided by 10. This is the next thing we'll do, and then we can return at the end reverse value. So this would be our method. So this would give me the reverse number, and whatever the more main method would be, we can there simply return absolute of n minus reverse value. So this is about the approach, these two approaches that we have discussed. Now let's discuss the time complexity for this approach, right? So for this one, we already discussed approach would be time complexity would be number of digits and space would be of 9, that is the string value. Let's discuss this maths time complexity, though it would be also same. If you see, what we are doing is, while reversing we are actually traversing each digits, right? So we have to traverse over all the digits. So it would be O of number of digits. So if we just simply say it's number of digits, but if you see what is the max value that we have as of now for digits, right? So that is 10 to the power 9, right? So if we want to know the number of digits, what we can do is we can simply do log of number x base 10 plus 1. So this tells me total number of digits. Now if I place 10 to the power 9 over here, so log 10 base 10 power 9 plus 1, and this will give me 9 plus 1, that is equal to 10. So in this number the value is total number of digits is 10, and that would be the time complexity. So if we generalize this, instead of number of digits we can say it is log of n, right? This is our time complexity. And if we see the space complexity, so here we are not using any additional string or anything, so space complexity remains O of 1. So this is about time and space complexity for this approach. The only difference from this approach to this approach, it has this additional space. Additionally, if in general, if you see, the mathematics is comparatively faster as compared to when we are having these three operations being done one by one. So yeah, that's all for this problem. And this problem was actually second part of yesterday's Leetcode challenge. I hope you might have seen that. If not, I will attach the YouTube link for that in the description below. Thank you for watching. Have a good day.